S. So we all know about stack. Stack is a linear data structure where we are inserting and deleting data through an end called top. Okay, so through the top is a pointer through which we can insert the data and delete the data. And the operations of stack are push, pop, peek, display, is full, is empty are the operations of stack. So these we saw in the introductory part of stack. Then after that, in last DSA class, we saw what is postfix expression, and we tried to convert infix to postfix expression. So infix expression is something you have operator in between two operands. Okay, so from that we have converted to postfix expressions like from that we have converted to postfix expression. Okay, so infix expression is a plus b is an infix, and postfix will be ab plus is your postfix expression. So I hope you all remember these basic things that actually you should have known when you are starting to learn the application of stacks. Okay, so in application of stack there are many applications. So in that we saw how to convert from infix to prefix in last class. Okay, infix to prefix. Okay, so now today we are going to learn the evaluation of postfix expression. So now from the so you got an expression like this and you have converted to this. Now if we substitute values for each expression, each operand, that is if a is equal to 5 and b is equal to 10, now we are going to learn how this 5, 10 plus is calculated in computer by using stack. Okay, for this conversion also, for this evaluation also, stack is used. Okay, so now first we saw what is stack, then we saw how to convert infix to postfix. Okay, now we are going to see how the converted postfix can be evaluated by using these formulas. Okay, so I hope you are getting you are just understanding what we are going to see in today's class. Okay, so with an example we'll solve how to evaluate the postfix expression. So now in our hand we have postfix expression. So with that, by using the formulas or rules, and we are going to evaluate the postfix expression. Okay, so I'll start with an example of how to convert. Fine. So this is the okay. So the example that I'm okay. So this is the example I'm going to take. 4 2 minus 3 5 1 plus and star plus. So this is the expression. Okay, so now see this is an algorithm you should follow. The same thing I have posted in PPT also. So this algorithm you just have it. Okay, so we'll solve. I'll tell you how to solve it. Okay, so we are same wise we are going to use stack to solve this evaluation part. Okay, so first what you have to do is so here the first algorithm, first step is begin for each character in postfix expression. So whatever this is a character, this is a character, this is a, so whatever the character you got, you have to do these things. Okay, first is read postfix expression from left to right. So we have to read always from left to right. So you all know this is postfix expression because you got operand and the operator at the end. So this is a postfix expression. Okay, so if the expression is postfix, then we can evaluate. Okay, so now I start. We'll start from left to right. The first expression is 4. Okay, 4 is an operand. Okay, so 4 is an operand. Fine, and okay, so if operand is encountered, push it onto the stack. So this is the stack that I have created. So there in conversion, whenever operand is encountered, we'll print it on output screen. But here it is just it is different. Okay, whenever operand is encountered, push it onto the stack. So I'm pushing the operand onto the stack. Okay, so please remember the difference. Okay, next is 2. So 2 is also an operand. Okay, so whenever by rule number 2, if the operand is encountered, push it onto the stack. Okay, I have pushed. Next, minus. So minus is an operator. If operator is by rule number 4, if operator is encountered, pop 2 elements. Okay, so I have encountered an operator now. So operator I have encountered. Okay, pop two elements. So 2 and 4. So this is the top now. Okay. From the top, you pop two elements. So I have popped these two elements. Okay. Please listen this clearly. A is the top element. So this element is called as A, and B is the next to top element. So B is next to top element. Okay. Now evaluate B operator A. So you have to evaluate B operator and A. So if you evaluate, what happens? So now the operator is minus. Okay. From the question we got operator is minus. What is B here? 4 and A is 2. So 4 minus 2 is 2. Okay, so the result we got is 2. Okay, so we have popped two elements and we have popped in a way that, and we have evaluated these two popped elements in a way that it should be B operator A. Okay, so B operator A is 4, which is B here. The top element is A, the next to the top is B. Okay, so this is B and this is A. So I have evaluated 4 minus 2. So if you are evaluating in this way, then you will get a right answer, or else you will get a wrong answer. So okay, so I have popped it. So I'll delete these two elements. Okay. Okay, so I'll create a stack once again. So I have deleted the element. So there is no element inside. What you have to do after the evaluation, push the result onto the stack. So what you got here, 2 as result. So 2, you push it onto the stack. Okay, now this is your top. Okay, so now we pushed 4 and 2 inside. We evaluated by using this operator. Now the answer is pushed again into the stack. Now next element is 3. So 3 is pushed onto the stack. Next is 5. Since it's an operand, so we are pushing it onto the stack. Please remember this. And finally, it is 1. So 1, I have pushed it onto the stack. Next is plus. Okay. So plus is an operator. Okay. So plus is an operator. So whenever the operator is encountered, you have to pop two elements. So this is your, so I forgot to increment the top. So top will be here now. Okay, so whenever the operator is encountered, pop two elements. So I popped two elements. Okay, so pop two elements, which will be B, this will be B, and this will be A. So you have to evaluate in the terms of B operator A. Okay, so which is B, 5 plus 1 is equal to 6. So what you have to do after, once the evaluation is done, you push that element into the stack. Okay. Okay, so now I'll push this element back to the result into the stack. Now top is this. Okay, next is star. Star is an operator. Okay, so operator, whenever you are encounter operator, you pop two elements from the stack. So this and this is popped. Okay, so this is my top now. Okay, so 6 and 3, this is A, this is B. So B is 3, this is 6. So 6 3s are 3 6 are 18. So once you got this answer, you have to push this element inside the stack. Okay, so top will be incremented and 18 will be pushed onto the stack. So this is your new top. Okay, last is plus. So again, you got an operator. So you have to push two elements from the stack. This is A and this is B. So 2 plus 18 is equal to 20. So the evaluation of Postfix expression for the particular expression, the answer is 20. Okay, I hope you understood this. So by following this particular algorithm, you can solve this converted Postfix expression into a answer. Okay, sometimes you will get an infix notation along with the values. So that time you have to convert from infix to postfix. Then you have to apply the values for each element. Then you have to get a right answer. So I'll help you with another example. Okay, so it's a simple sum. 6 3 minus 2 star. Okay, so 6 3, since it's an operand, 6 is an operand, so you push it onto the stack, and 3 is also an operand, you push it onto the stack. Okay, so minus is an operator. So whenever you get an operator, you'll pop two elements from the stack. So top will be this. Initially top was this, and the top will be your B. Okay, top will be your A, and this will be your B. So you'll be using B minus A. That is 6 minus 3 is 3. And once you got the result, you push the elements inside the stack. Okay, so 3 is inserted again. The result enters into the stack. Then is 2. Okay, 2 is inserted into the stack. Next is star. Star is the operand, operator. So you'll push 2 elements from the stack. Since this is the top element, so top will be considered A and this will be considered B. So 3 star 2 is 6. So this is your output, or this is the answer. Okay, so likewise, you have to evaluate the Postfix expression. So I hope by this you would have clearly understood the purpose of the application of stack. Okay, so initially the stack is a linear data structure where you can do some operations like push, pop, okay, peek. These are some operations of stack. From that we learn how to convert from infix to postfix expression. Okay, once you have in this infix to postfix, okay, so why we are going for infix and postfix? It's an application of stack. Okay, so one more thing, in my class I have told already, compiler doesn't understand this infix notation. Okay, but humans will understand A plus B. We'll just substitute the values of A and B and we can evaluate it. But humans can do it easily, but computer compilers will not understand this kind of. It will understand, but it will take long time to solve this kind of answer. So what the mathematicians did, the engineers did, they have developed the postfix notation and they have converted this infix to postfix notation. This will be understood by the compilers easily. Okay, so that only we are going for conversion, and this conversion is done by using stack. Okay, so stack is a data structure which can convert infix and postfix notation. Okay, which will help the computer to solve the problem very easily. Okay, so then we saw how to convert infix to postfix by following some set of rules. Then today's class we saw how to evaluate the postfix notation. Okay, by using the same stack data structure. Okay, so I hope you understood today's class. Okay, 1 minute.